In this video, we will study about the armamentariums used in dental implantology. Dental implants can be used to retain single crowns, fixed partial dentures, full arch bridgework, and removable prostheses. The use of dental implants is well established and high survival rates have been reported. Implant dentistry now forms a significant part of general dental practice and patient awareness is steadily increasing. So what is an implant? Implant is a prosthetic device or alloplastic material which is implanted into the oral tissue beneath the mucosal and or periosteal layer and or in the bone to provide retention and support for the fixed and removable prostheses. Coming to classification of dental implants, depending on the placement within the tissue, it can be an epithelial implant, it can be an epiosteal or subperiosteal implant, endosteal implant, or transosteal implant. What is an epithelial implant? The implant that is inserted into the oral mucosa, that is known as epithelial implant. The main disadvantage is it is painful. It has a painful healing procedure and it requires continual wear. Coming to epiosteal or subperiosteal implant. The epiosteal or the subperiosteal implant receives primary bone support by resting on it. That is, it receives primary bone support by resting on the periosteum. It is placed directly beneath the periosteum overlying the bony cortex. So, beneath the periosteum we have the bony cortex. So, this implant is placed beneath the periosteum and it overlies, it lies over the bony cortex, not inside the bony cortex but above the bony cortex. The main disadvantage is it is slow, predictable rejection of the implant. The bone loss associated with failure is also seen. Coming to transosteal implant, it is also called a staple bone implant or transmandibular implant. It penetrates both cortical plate and passes through the entire thickness of the alveolar bone. So here both cortical plate means it penetrates both the buccal as well as lingual cortical plates and it passes through the entire thickness. This is the entire thickness of the alveolar bone. So it penetrates through the entire thickness of the alveolar bone. But it is used mainly in the anterior area of the mandible, not in the posterior region, only in the anterior area of the mandible. Now the endosteal implant, it extends into the basal bone for support and it transects only into one cortical plate. Unlike the first one that we have read, it transects only one cortical plate, not two. The endosteal implant can be either of root form type, ramus frame implant type or plate form. Now the root form implant type is used over vertical column of bone. And it can be cylindrical or screw shaped or a combination of both. The implant body has three regions. That is the crest module. This is the crest module over which the abutment sits and the body and apex. So there are three parts of an implant: crest module, body, apex. The second type of classification is depending on the type of material which is used. It can be either metallic or it can be non-metallic. So the metallic implants, commonly used metals are titanium, cobalt, chromium, molybdenum alloy, titanium, aluminium, vanadium alloy, cobalt, chromium, molybdenum, stainless steel, zirconium, tantalum, gold, platinum. Now coming to non-metallic implants, it can be either made up of ceramic or carbon. Depending on the reaction with bone, implant can be either bioactive or bioinert. Bioinert implants are generally metallic implants only. They do not have any coating on their surface and they do not induce the formation or stimulation of bone formation, whereas the bioactive implants, they have a coating of either hydroxyapatite, tricalcium phosphate or calcium phosphate on their surface, and they stimulate bone formation. Coming to the armamentarium that we use for surgical procedure for an implant placement, the various armamentariums are console, motor and handpiece, classical surgical setup, a starter burr which is generally number 4 round burr, pilot drill, osteotomy drill as provided by the manufacturer, burr extender, paralleling pins, depth gauge, a ruler which is generally a millimeter ruler, and implant system of choice. Within the implant system we will get countersink, final sizing drills and trine. Next is a torque driver which is provided within the implant system, and a surgical template for it is a guide for implant placement in case if you are placing multiple implants. So this is the surgical setup of the instrument tray. We have a mirror, periostal elevator, Mole's elevator is used, periodontal probe, cotton forceps, instrument for removing tissue tag like a scaler, Castroviejo caliper, Castroviejo type of needle holder, suture scissors, tissue forceps. Then we have a hemostatic forceps, implant torque wrench, the gauze of 4x4 size and 2x2 size, topical anesthetic solutions, anesthetic needle, anesthetic syringe and BP blade number 15. This is an implant console of NSK system. Here you have all the electrical circuitry. It controls speed, irrigant, the handpiece selection button is there. The forward and reverse button is there. Even the foot controlled rheostat plug is powered by the This is an implant motor setup. The motors generally have a RPM of 20,000 to 40,000 RPM. Surgical setup of implant motor: assemble handpiece and connect to implant motor console. Assemble saline supply and make sure tubing is mounted correctly in peristaltic pump. Close tube lock to prevent spilling of saline while motor is not used. Mount the pilot drill and turn on unit to verify its function. Handpieces used in implant dentistry. Handpiece is any apparatus which is attached to an electrical or an air or nitrogen powered motor that accepts a burr. So there are two types of handpieces that can be used. One is contra-angled and the other one is straight handpiece, and these enable the practitioner to increase or maintain a motor speed reliably. So once you have done the setup of your implant motor, we start doing our implant area preparation using a round burr. So round burr is sometimes used to prepare implant site before creating an osteotomy cut. It is mainly used to create a flat ridge prior to osteotomy creation so that implant platform is level with surrounding bone. Next we use a pilot drill. It is a first rotary instrument. It cuts bone at the tip and at sides also. It is used to mark osteotomy site mainly. It is used to cut through the cortex at osteotomy. It is also used to correct osteotomy location or direction by removing bone from side of osteotomy. Next comes the osteotomy drills. Osteotomy drills create osteotomy shaped like an implant. It mostly cuts at the tip. The depth marks indicate implant length. So every company has various osteotomy drills. As per their manufacturing guidelines, there are certain depth marks made on the osteotomy drills and you have to follow the manufacturer guidelines, which varies from company to company. Next we have a paralleling tool, which is a direction indicator. It is used after creating first narrow osteotomy. It shows direction of osteotomy clinically and radiographically. It often features hole to tie a floss through it, so it is less likely to be aspirated. Sometimes it features markings also. So it is simply a metal pin of the same size than the first osteotomy drill. It is a dummy implant to show where implant would be. Next we have implant drivers. They are used to deliver implant into the osteotomy site. The implant drivers can be attached to the handpiece or it can be used mechanically using the torque wrench. So the hex is basically a implant driver. It is known as hex because the cross section is hexagonal. There are different size of hex for different implant platforms. So this is how an implant wrench looks like. Now coming to the prosthetic armamentarium. To effectively carry out any procedure, it is crucial to familiarize oneself with the components involved. The first step is to determine the implant system that you are using, because this will dictate the type of impression component that you are going to use. Each implant system has its own set of impression components that are designed to fit accurately onto the fixture head of the implant, which is machined to specific geometry. So irrespective of the implant system used, the impression components and techniques are broadly very much similar. This is how a noble fixture head looks like, and this is how a brain mark fixture head looks like. Screwdrivers. It is a prosthetic component. An implant screwdriver is a critical piece of equipment used to screw and unscrew various components into the fixture head. Depending on the implant system, screwdriver heads can be slotted, hexagonal, star-shaped, etc. They are often designed to fit into a manual or motor-driven torque device, which can be used to tighten components to a predetermined torque. The implant fixture head is usually at the level of the alveolar bone crest. Therefore, in order to provide access to the fixture head, a removable transmucosal component, which is known as a healing cap or healing abutment, it is screwed onto the fixture head by the surgeon. It can be done either at the time of implant placement or as a second surgical procedure later on. And these healing abutments or caps, they vary in height, width and profile. An appropriate healing abutment is selected to mold the peri-implant tissues, that is implant surrounding tissues, during healing and preventing tissue overgrowth. Coming to impression coping. The impression coping is the component that fits onto the implant fixture head or an implant abutment while making an impression. So there are two types of impression copings. One that is used with a closed tray and it is retained in the mouth after the impression is removed, and the second one is used with an open custom tray in which the impression is removed with the coping in situ within the impression. So once cast is made, the impression copings transfer the position of the implant fixture abutment head onto the working model on the cast.